Hey everybody, this video is about friction, which I mentioned before is a component of contact force. Right, so let's say like you're trying to pull this box toward the right, and then so then you're applying a force this from the person, and then there's going to be a contact force because the box is in contact with the ground. So there's a contact force, let's say like this way, contact force. But we can decompose the contact force into components, one that's normal to the surface and one that's parallel to the surface. So this is the force normal to the surface, we just call normal force. The component of the contact force parallel to the surface, we call friction. And there's weight. Okay, so these are the two components of the contact force, and it turns out they're proportional to each other. Okay, so, and then also imagine like if you pull the box with 1 Newton of force. So let me make a graph. This is friction. So you pull with 1 Newton of force toward the right, and then the box doesn't move. It remains static. Then that means there's got to be 1 Newton of force to the left, since the acceleration is 0. Right, so this force has got to be the same magnitude as this force. And then you apply 2 Newtons of force. So then there must be 2 Newtons of friction. 3 Newtons of force, 3 Newtons of friction. So the more force you apply, the more force by friction fighting against you. Until at some point where you pull with enough force, the box actually starts sliding. And then that friction will be called kinetic friction. And the weird part is, it actually takes less force to keep it sliding than it did to get the box moving in the first place. Right, so this region here is static, and then here is kinetic. So see how the static part, right, friction is on this axis. It actually can be higher than the kinetic friction. So kinetic friction is just this constant, but static friction is a range of values that maxes out somewhere over here. Okay, so let me write down what I said. Kinetic friction, I'll call this kinetic friction. It's a constant and ends up being proportional to the normal force. Here. So this is kinetic friction, which is a force in newtons. This is normal force in newtons. So if this is newtons, this is newtons. This is a dimensionless coefficient, which we call the coefficient of kinetic friction. Okay. Right, so you see friction is proportional to normal force. Friction is proportional to normal force. The two components of the contact force are actually proportional to each other. And then similarly, you can have static friction, which is proportional to normal force. And now this is the coefficient of static friction. Okay, and there's one detail. This static friction we just said was a range of values. It's not just a constant. So what I wrote here is not a range, the range is like this. Right, so it's less than or equal to this. So this is the maximum value. Mu s times n represents this point right here, the maximum friction. It's actually at this entire range here. Okay, so stay tuned for future videos. We'll do a bunch of examples. I'll see you on those.